switch, it's on. That can go in your
Thank you.
pocket.
My name is Kirill Kolyshkin, and I'm with Parallels and OpenVZ project. Been maintaining that for a while. One of the goals of OpenVZ project was to merge the container stuff upstream, and we were actually working on that way before they were called containers. We had the term virtual environment back then, and operating system level virtualization when we came up with the term containers. I think it was actually Solaris who came up with the term. But basically, now we have reached the point when probably about 80% of the stuff that we need in the kernel to run containers is already there upstream, and therefore we can now use, historically OpenVZ is a huge patch set to the upstream kernel, and we are working bits and pieces, moving those bits and pieces upstream with the help of a lot of other guys, and currently we are like 80% there. And at this time we can make using OpenVZ kernel optional. So what we figured out that we have our own set of user space tools. It's mostly VZCTL plus a few other tools like that. And they are more or less in line what LXC tools are. In addition to that, I just found that Google has their own set of tools for containers. The definition of containers are a little bit different for us in Google. Google mostly use control groups for resource management. And at OpenVZ, we mean container is something that is very similar to VM as much as it can be run in a full distro. And say for Docker, container is something else, as in like an application container. But my proposal here would be to somehow find out how can we have a common set of user space tools, not repeating the functionality of one another. So I guess I can just do a quick demo of what tools do we have in OpenVZ, just a few minutes, and then that maybe Stéphane could do the same for LXC, like a real quick cycle of create and starting. So this is VZCTL 4.5, and since version 4.0 we can use unmodified 3.x kernel and use the functionality that it's already there. And the other tool, okay, let's start with VZCTL. First of all, then we create container. It basically means we create a file system, a set of files for the container. And here you can specify the template. The template is usually a distro that you need to run. And let's say Ubuntu. And we can also specify stuff as like disk space for container and some other things as well. Oops. Okay. As you can see, there is a built-in functionality to get those templates, the pre-created container images. If they are not there, they will be downloaded. But I guess we just use something that is available locally. In this scenario, I'm using the ploop device, which we are aiming for merging upstream in 3.13 or so. At this point, we are just untarring that container to a huge loop device. and this is more or less it. When the container is created, it's just a file system. We haven't started it yet, and we have this configuration file that we can look at. It's just a set of parameters down, so it can be parsed from C and Shell pretty easily. In Shell, you just source this file. And here we have the physical RAM limit, swap limit, disk space limit, and various other parameters like CPU weight, and that's it. And then we can add AP to this container. Let's say something like this. Since the container is not running, this new IP is just added to the configuration file and nothing else happens. In case the container is running, these new parameters are applied to the running container as well. So we can now start it. And here we have, it's just a minor thing, but it matters. We have the bash completion built in. So for example, then I type vzctl start and press tab 2 times. It gives me a list of containers that can be started, basically stop containers. This file system is mounted and all parameters are applied. And speaking of, for example, application of IP address, it's kind of dual here. Like you have to have, we use route-based networking by default, so you have to have a route on the host system for this container. Plus, you have to modify something inside some configuration files inside the container to put that IP address in. And this is very distro dependent. For example, for Ubuntu, this would be etc network interfaces. For Fedora, that would be etc sysconfig network or something. For Debian, it's the same as for Ubuntu. For Arch, it's completely different. For Alt Linux, it's completely different. So, big part of vzctl is those distro-dependent scripts to do different actions inside the container. This knowledge. So the container is now running, and we can enter it and see what's inside. It's like usual set of process starting from init and all the daemons. Basically, we have the usual Ubuntu thing. What we can do, we can stop and destroy the container. But let's do a snapshot, for example. What snapshot is basically what Pavel was talking about, crew. It saves the complete state of the running process inside the container. Plus, vzctl snapshot does a file system level snapshot for the container files. Combined together, this is the full working snapshot of the running container, which we can restore later, roll back to later, or we can migrate later. So this does the file system snapshot using ploop, and this does the either crew snapshot or the similar functionality that we have in mainline. And then we can, I don't know. Yeah. All right. So basically, this is a list of snapshots. One other thing, this is all about vzctl: start, stop, exec, enter, destroy. We have some more tools, like vzlist, for example. It shows you the containers, and you can have it show specific parameters for specific containers. It's yet another way. Instead of reading config, you can ask for how many running process does this container have, or what its disk space. So it's basically a way. And the good thing with this is it can do the same in JSON format. So could you do like the same for LXC, right? And I compared the I compared the source code, the C code is about the same number of lines to 20,000 lines, I guess. I'm not sure how much shell in that. Oh, and we also have a lot of man pages, pretty, well, at least like 40 pages if converted to PDF.
So yeah, just two questions about your demo. So I guess that in your config file just show this 1016 thing. I think the namespaces setup is kind of implicit.
Yeah, by container we mean all the namespaces and all the resource groups that are available.
So which means that like you don't give the ability to the user, they can pick which namespace they want.
Yeah, we don't have that capability, but we are thinking of adding one to make this more elastic. Or
okay, and I guess for the auditoring thing that you show what is inside for the container, all this kind of stuff, you don't show the namespaces as well.
I mean, inside the container looks like you have your own physical server. I mean, we care much about the container to look like a VM, so you can just run stuff. Right. But this is just one option. It's not like.
Okay, so another question for I see that you're operating on the container based on the number, like the number you show is 1016.
Actually, we also have names. So currently the number stays as a primary unique ID,
sure.
But you can also give a name to container and then call it by name. And name is just implemented as a symlink to the number. Actually.
So I assume that you embed that number into the cgroup file. It's a cgroup file that you created for the container has that number embedded.
Yeah.
Okay, so that how you maintain, how you keep that consistent for doing the dump and
if there
restore.
is a system with many nodes,
yeah,
the container ID has to be unique. What we're going to do is we're gonna implement the GUID instead of that 64.
The long
that
UUID
long screen
format.
that's supposed to be unique. And then you still can have the name as a like alias, and then if you migrate it and if the name is not available, then you can just drop it, right?
Okay.
Or you can. Yeah.
Okay, so I'm going to try and do the same thing really quickly for Alexei, because we still have a 15 minutes talk after that, and we're supposed to finish in 5 minutes. So, Alexei, instead of having one big vzctl command, we have a bunch of smaller separate commands. So if you do Alexei dash and look, there is quite a bunch of those. If you want to create a simple container, you do Alexei create -t for template name of the template you want. So Ubuntu in this case, and then -n, name of the container. In this case, it doesn't download because it's already cached locally. So I can spare you 20 minutes of downloading stuff. It's still slow enough, right? It generates new SSH keys, replaces the different places in the container that should really be unique. Once that's done, you can check all the containers on the system using Alexei list. That gives you all the container names, their state, IPv4, IPv6 address, and whether they're auto-started at system boot. Starting that specific container can be done with Alexei start. I'm going to start it in the background instead of foreground. So just do -t. I can confirm that it's started apparently with IPv6, considering how large that screen output is now. There it is. So I can then enter the container using SSH, for example. And I'm in a container standard Ubuntu system that just got created. Absolutely, yes. So if you have a recent enough kernel, you can do Alexei attach and then container name.
And are you attaching to the get daemon?
And you get attached in the container. So Alexei attach by default attaches to all the namespaces and directly to the container and throw routes into it. You can also decide that you only care about the network namespace. Like so. So you see that it didn't change directory. I'm still on the host, but if I do fconfig, I see my container. So you can attach selectively to what namespace you want if you just want to run a single command in it. Yeah, it makes it extremely nice because you can just attach to the network namespace of all the containers, do something in there. One of my things I do in my spare time is try and simulate the internet. So I simulate like a 500 nodes BGP internet. And it's really nice being able to just attach to all those network namespaces and look exactly what's going on in each of my fake countries or whatever. Besides that, just the config quickly. All containers in LXC are invariable LXC by default. You've got one directory per container. Each directory contains a config. It might contain an fs tab file and contains a rootfs directory with the actual content of the container. The config contains network configuration, then the root file system, a bunch of other options. And we've got the generic lxc.cgroup.controllername. Something, and we can just, where you can easily set any cgroup parameter directly. One thing we don't support choosing what namespace to clone when the container starts, but you can choose not to have any network configuration in the file, in which case we don't clone the network namespace and you get the host network namespace.
Basically, you stay in the root.
Yes, you stay in the root. That's exactly what I'm doing for Android, because Android relies on using the loopback to communicate with the outside. So with Android, I don't even use any of the networking stuff. LXC supports integrating with kernel capabilities, with cgroups, with seccomp, and with AppArmor currently. And some people are looking into hooking with SE Linux. Yeah, can try that. Kind of hard with one hand, but. So we have the API, as I mentioned, so you can do import LXC. It says that it's not stable yet, which is the point because 1.0 has not been released yet. Okay, so now test is my container. I can check the state. So we say that it's running. We can check the IP addresses. We could call create again to wipe the root file system, generate a new one, or we can use get config item to get some keys, or set config item to get some others. We can also access .networks, which gives you a list of all the network interfaces in there that you can work with. Or you can do more simple stuff like stop, which will just stop the container. So yeah, everything that's available in the C API is available in the Python API, and we are trying to put everything in the C API. So in theory, you can do absolutely everything in Python, Lua, or Go currently using that API.
So for the LXC attach, like after you enter the namespaces, like what's the UID and the capabilities looks like?
If you do LXC attach, by default, it will get the same capabilities will be dropped, and it will be attached to the same C groups as the container itself, unless you pass a command line parameter that says you don't want to do that, which you can decide to. So you could attach a process that's only attached to specific namespaces and doesn't have to respect the C group limitations and the AppArmor profile, for example, of the container. LXC attach is meant to be really, really flexible, and the version in the API, like in the Python API, is even more flexible. You basically set a bit mask of exactly what features you want, and then it runs your code in there. Okay.
So the question remains, can we somehow
Right.
not have to, as I see they're very similar from the user perspective, right?
Yeah, and I'm going to just cover that really, really, really quickly because we are really, really quite late. I think both projects currently lack their command line tools, and it would be nice if we could maybe at some point, I don't know, rename the liblxc into libcontainers and maybe get both projects basically be different tools using that library, so at least we can avoid some duplication in that area.
By the way, are you using libc group?
I can't remember. Do we? We don't use libc group at this point, right? We don't use libc group. Right.
Okay. So
We
you set this groups manual. Okay.
Yes. We had some issue with libc group initially, I think. Yes. Okay, so last talk of the day.